Okay, dear students, so this is Professor Varun, and in this video, we are going to learn about conduction, specifically about conduction. Now, there is a law in conduction, okay, that is called the Fourier's law, conduction, and the name of the law is Fourier's law. Now, this topic was not in the old syllabus, and even conduction was very small part. And there were no questions that we expected from conduction in the old syllabus, but in the new syllabus, this topic has been added recently. So it means that this topic becomes very important for the new syllabus students, clearly because it is added just now, and we would be going into further details, like quite details for this topic. So this is very important for the new syllabus students. The old syllabus students need not to watch this. Okay. Now, so Fourier's law is it is applied when the conduction is taking place. Now the conduction will be taking place through the metals, through the conductors, through rods. So we are taking the example of a rod here. The length of the rod is D. The area, the cross-sectional area is written as A. Now, the another very important factor is the thermoconductivity. I will be telling you about this later also. Thermoconductivity, this is a factor which tells you how good is the thermal conductivity for that particular material. Like for example, you might be using wood instead of a metal. So we will say the thermoconductivity of wood is very small. It's very bad. But for the metal, thermoconductivity K value is very high. Now, what else we want to know here? So this is TH, the high temperature on this side, and this is the cold temperature. It is written as TC. The temperatures at both of these junction is maintained. It is not a variable. So this temperature is never going to reduce whatever heat flows out of it. And this temperature is never going to rise whatever heat is given to it. That is our condition. Such is known as infinite source, and this will be known as infinite sink. Like you can give whatever amount of energy, heat energy to this source, then like this we can say reservoir. So the temperature of the reservoir is never going to increase, so that is why it is known as infinite sink. Okay, now TH is greater than TC, everything is known. Now, what is this Q here? So, Fourier law says that we actually are not interested in the amount of heat that has flown. We are interested in the amount of heat which is going through the rod per unit time. It is flow rate that becomes very important in this topic. Till now, like in the other part of B, what we did, Q is equal to MC delta T. Another formula that we have learned is the latent heat, which is Q is equal to M into L. In both of the cases, it is the energy that you are concerned with. It is the total energy which is given to the body, which is used in increasing the temperature or melting the fluid, something that is important. Time is not a factor in these equations. But here, when we talk about energy transfer, we are interested in the rate of energy transfer. So basically, it is power. So what is the unit here? The unit is joule per second, or we can say watt. And here the unit is joule. Okay, so that is the difference. Now, according to the Fourier's law, the rate at which the heat is flowing in the rod is found to be directly proportional to number one, the temperature difference delta T, or you can say TH minus TC. Okay. Now, this is found to be directly proportional to the cross sectional area of the rod, this area, this cross sectional area. So heat is flowing through it like this. And what is the area through which the heat is flowing? That is A. So more is the area, more is the heat flow. Provided, like let's say we say that this is a hot body here, provided that the temperature is not going to vary within the body. Obviously, if it is a bigger area, then there is a bigger area from which the heat energy can flow out. So there will be more energy flow rate. It is directly proportional to the cross sectional area. Simple. So this is directly equal to A. Now, it is inversely proportional to the length of the rod. So, longer is the rod, more becomes the thermal resistance, you can say, more becomes the problem, and the energy is having a problem in reaching to the colder junction. So, it is taking more time. So, definitely, it is inversely proportional to the length. Now, from this, we created a formula. We try to introduce the equality sign in our equation. So it will become delta Q divided by delta T is equal to, we have to introduce a constant of proportionality. In this case, it will be thermal conductivity. The coefficient of thermal conductivity is known as, so K is multiplied, A is multiplied, delta T is in the numerator, L is inversely proportional, so it goes to the denominator. So this is the formula that is in front of you. So delta T is basically the change in temperature there. L is the length, A is the area, K is the thermal conductivity. So this becomes delta Q by delta T. This is thermal conductivity. Okay. So this rate is also written as Q dot. Okay, Q dot. This is also written as Q dot. This is how we write it. So there is nothing more to note in conduction. Like as per the Fourier law is concerned, there is a rod, and how do we think on it? The condition there is, do not forget it please. The condition there is that the TH is having a constant value, it doesn't change, and TC is also having a constant value, it doesn't change. Okay, this is it. Now we are moving into the second part of the video, which is very important. Okay, so let me close the video here. It's already 6.5 minutes, so you can just move to the next video, and we would be talking about thermodynamic walls and others, which is a further topic of the Fourier's law, which is added into your syllabus. Very important video. Okay, dear students, all the best. Bye.